So today we're going to talk about graphing exponential functions, and we have been graphing all sorts of different functions. What's different today is that there is an x in the exponent, and that is what classifies this as an exponential function. So some things that exponential functions always have in common is, make a t-table, is if you plug in 0, 2 to the 0 is 1. And whatever the base number is, 3 to the 0, 4 to the 0, 5 to the 0, anything to the 0 is always 1. And so this point over 0 up 1 is consistent with any parent exponential function. To get a few more points, I'm going to plug in 1 and 2. So 2 to the 1 is 2. 2 to the 2 is 4. I'm just plugging numbers in for this exponent. I'll try -1. 2 to the -1 is half. So that gives me some points to start with. And we could do more, but I kind of see the general shape here. It is curving upwards and goes down like this. There is a horizontal asymptote at y equals 0, and some of these things are true all the time. So we are going to talk about what is true all the time with the general exponential parent function, which would just be a to the x. So we're not being specific here, we're being very general. So first thing I'm going to do is take off the scale, and when I do my t-table, a to the 0 is 1. So wherever, whatever we have for a, 0, 1 would be a point. When you plug in 1, a to the 1 is a. So over 1, and then however far up it is, this would be over 1 up a. Here it was over 1 up 2. Could be over 1 up 3, over 1 up 4. Whatever that base number is, that's going to be how far up you go. This would be a squared. So over 2 up a squared. Again, this is very general, so whatever a is, it really depends on how steep this will be. If a is 2, it's not super steep. The bigger the number, the steeper the curve. And then here, a to the -1 simplified is 1 over a. So that's another one that is nice and common to have. Always has a horizontal asymptote at y equals 0. So those are some things that every exponential function would have in common. Now we are going to take the parent function and transform it, and I did this in 2 separate steps just so it wouldn't be too confusing. So the first thing is, if you have a plus a number on the end, like a +2 or +3 or +4, that k will move it up or down k units. That is consistent with the transformations that we've learned earlier this year. This h, there's a negative in front of it because you always take the opposite of whatever it is, but that would move it left, I wrote right, left or right h units, and that is still opposite of the number that you see there. So if it's -2, it would move it right 2. Here we have a few things added. If there's a negative in front of the base, that would reflect over the x-axis. Same transformation rule as before. And here, if there's a negative in the x in the exponent, it would reflect over the y-axis. The thing that you don't see me writing here is stretch or compress, and that has to do with the base number. So base number will affect steepness. So that is equivalent to the stretch or compress that we had before, but with an exponential function, it's going to appear like it's either getting steeper or less steep depending on the base.